This video is intended to help California growers and producers set up and run the Water Right Water Balance Irrigation Scheduling Program. The Water Balance is a simple program that allows you to be up and running very quickly. This scheduling program was developed by the Center for Irrigation Technology at California State University, Fresno. Any field data and information you enter into the program is maintained in a secure database at Fresno State and will not be shared by any entity. To begin with, go to the Water Right website, which is waterright.net. This is the main Water Right website that includes different programs. In the top left-hand corner of the screen, click on the Water Balance button. If you are a first-time user, you will be directed to the registration page as shown here. First-time users must register. Select a username and password and enter your email address. Next, select a security question that can be used in case you forget your password. After registering, you can log into Water Right and start using the Water Balance Irrigation Scheduling Program. To use the program, you will need to enter 5 different types of information, which are the name of your field, your crop data, the selected weather station for your field, your soil data, and your irrigation system data. More information about the required data is given in the user's guide, which can be accessed from the main Water Balance page. First, you need to pick a name for your field. We suggest using a field or block ID plus the cropping year and the name of your crop, such as Block A 2016 tomato. You can have multiple fields with different crops and scheduling programs. Just click on New Field to add more fields. Your field data and calculations will remain in the database, so you can compare irrigation scheduling of the same crop from year to year. After selecting a name for your field, go to Crop box and select your crop from the drop-down list. As you can see, all the default crop information will be automatically populated for the selected crop. Here you will need to carefully review the dates for different growth stages and also crop coefficient values and make changes for your field conditions as necessary. If you need additional crop information, click on the information icon on the right side of the screen for crop help. After completing the crop data, go to the CIMMYS weather station list and pick a neighboring station for your field. The selected CIMMYS station should represent the weather for your field location, particularly solar radiation, air temperature, relative humidity, and wind speed. After selecting the weather station, select a soil type for your field from the list. The first 2 boxes of the selected soil type show the initial and maximum managed crop root zone. This determines the effective root zone that can store soil water for irrigation scheduling purposes. For annual crops, the initial root depth should represent the seeding depth plus an additional depth following germination, usually 6 to 8 inches. For perennial crops, the initial root depth is the same as the maximum root depth for irrigation scheduling. The maximum root depth for both annual and perennial crops is the managed effective root zone to store water and fertilizer for plant uptake. Other required soil data include field capacity and permanent wilting point, which are considered the upper and lower limits of available soil water. The available soil water is held between field capacity and permanent wilting point. Field capacity is the soil water content after a heavy rain or irrigation when the soil has been saturated and allowed to drain freely for a few days. Permanent wilting point is the soil water content when plants can no longer extract water from the soil and will die. More information about soil available water is given in the user's guide, which can be accessed from the Water Balance page. The next required data is Management Allowed Depletion, or MAD. You will enter a percentage for the Management Allowed Depletion for your field and crop conditions. Simply put, MAD is the amount of available soil water between field capacity and permanent wilting point that is allowed to be depleted by plants between irrigations. On average, MAD is 50%, which means that plants are allowed to extract 50% of available water between field capacity and wilting point before the next irrigation cycle. For example, if you have a sandy loam soil with available water of 1.6 inches of water per foot of soil, and your MAD is 50%, then your allowable depletion is 0.8 inches of water per foot of soil. And if your managed root zone for irrigation and fertilizer applications is 2 feet, then your total allowable depletion is 1.6 inches of water before an irrigation. More information about this subject is given in the user's guide. The last required data in the soil type section is the soil volume used to store water. You will enter a percentage value here. In localized irrigation system, particularly single hose drip emitters in orchards, not all the soil area is wetted by irrigation. For example, let's consider an orchard on drip emitters with a single hose and tree spacing of 17 by 20 feet as shown in the diagram. 17 feet spacing down the rows and 20 feet spacing between the row of trees. Let's assume a medium soil for this orchard with 4 feet of lateral water movement beyond the drip emission point, as you see here. Assuming there are enough emitters along the hose, the width of the fairly continuous wetted strip is 8 feet, as you can see. Therefore, the maximum wetted area is only 40% when you divide the maximum wetted area by a single tree by the total crop area. The last set of required data is for your irrigation system. Select your irrigation system from the drop-down list. The required data includes irrigation system efficiency, flow rate, spacing, or area. Estimate your irrigation efficiency as it affects the gross amount of water applied to the field. In this scheduling program, the gross irrigation application input data is used so that you can track the total amount of water applied to the field. The irrigation efficiency that you input here will be used to convert net irrigation demand to gross irrigation amount to apply. Thus, changing the value of irrigation efficiency will change the water balance results. To prove your irrigation efficiency, you will need to improve distribution uniformity and minimize water losses. If you're not sure about your distribution uniformity and system losses, it is a good idea to have a professional evaluation of your field for distribution uniformity and irrigation losses. After entering all the required data, click on the Save Fields button in the top right corner first, and then click on the Prepare Water Budget button next to it. A water balance table for your field will be prepared as shown here. The first column is the date, which starts from your planting or green up date up to the current date, including a 7-day forecast, as shown by asterisk symbols next to the date. The second column is the potential crop evapotranspiration, which is basically reference evapotranspiration multiplied by the estimated crop coefficient. Potential evapotranspiration assumes that there is no soil water shortage. The third column is the adjusted or actual crop evapotranspiration, which is potential crop evapotranspiration multiplied by a soil water stress coefficient fraction. If there are water shortages in the root zone to satisfy the potential crop evapotranspiration. The fourth column is the gross irrigation deficit. This is the amount of water needed in inches to bring the soil back to field capacity. The gross irrigation deficit is also given in terms of hours of application or runtime. The fifth column is the gross water applied. You will enter the amount of water applied on the field during the irrigation event. Please note, this is a real-time irrigation scheduling, and the program does not apply water automatically to the field. Users should input the amount of water applied on the days of irrigation events. The sixth column is rain minus runoff. The default value for this column is the rainfall amount from the selected CIMAS weather station. You can adjust the default values. You may want to change this value to 0 for very light rain and adjust it downward for heavy and high intensity rains to account for any runoff. Do not forget to click on the Save Changes button if you're making changes here. The seventh column is the soil volumetric water content, which is calculated using the soil water budget. Obviously, there are uncertainties in the soil water budget calculations. These uncertainties can come from inherent errors in reference evapotranspiration formulations, underestimation or overestimation of crop coefficient values, and the amount of water stored in the root zone and used by plants. You can adjust the volumetric water content if you have reliable soil moisture sensors. If you change the value of the volumetric water content, the soil moisture in the water balance table will be adjusted for future soil water budget calculations. The last column is the percentage of available water content, which is calculated using the soil water budget. Available water content is the percentage of available soil water between field capacity and permanent wilting point. Available water content is 100% at field capacity and 0% at wilting point. You can also add charts to your water balance table. Just go to the top of the page and add the desired charts. There are a variety of charts, as you can see, and you may not need all of them. Please do not forget to click on Prepare Water Budget after selecting the desired charts to display the charts. You can also download or print your data for your records as shown here. When you return to your irrigation scheduling program, all you have to do is click on Prepare Water Budget to update the calculations and enter the irrigation depth if you have an irrigation event. You can also adjust the rain minus runoff data and adjust soil volumetric water content if needed or desired. We hope you use the water balance program for your scheduling needs. If you have any questions or comments, please contact us at the Center for Irrigation Technology at Fresno State.